I will introduce our first speaker. The keynote will be delivered by JB Onofré. He is an Apache member and director on the Apache board. So, JB.
Thank you. All right. Good morning, everyone. Thanks for intro and thanks for inviting me there. So, few words about me. So I'm JB. I'm based in France. I'm board member of the Apache Software Foundation, member of the foundation for 18 years, I think now. I'm committer or PMC member on roughly 20 Apache projects, and also mentor PPMC on 5 podlinks. So podlinks are the project into the incubator. And so I'm contributing on Apache Iceberg and also about Polaris. So I'm champion and mentor on Polaris. And I'm also principal software engineer at Dremio, as you can see there. So before talking about Iceberg and Polaris, let's see where these projects are located. They are in the Lakehouse ecosystem. So by Lakehouse, we need some kind of data storage that we can query easily. And if we take a look about the different components in the Lakehouse, we can identify, maybe you have other thoughts, but identify 4 layers. So the first layer is the storage. It's basically where the data files are located. It could be a file system, could be an object store, like S3, whatever. On top of that, we have a table format, is what we're going to discuss just after, so Apache Iceberg. And on the top, we have the engines, so Flink, Spark, Dremio, whatever. And between the two, we have a catalog. So the catalog, there are different meaning about catalog. You may have different view about catalog. Where I talk here is catalog in terms of meta store. We will see what Polaris is compared to the other Iceberg catalog. So the Iceberg, so about the storage, there are not much to say. It's a storage or object store, so nothing major there. It already exists, so you can use Apache Ozone, you can use S3, you can use whatever. On top of that, the difference between a storage and directly using a table format is basically when you have a storage, you have a raw data files. So you can directly access these data files and create yourself, whatever. So you can use Parquet files, you can use ORC file, whatever. But adding metadata on top of these data files bring a lot of new features. That's exactly the purpose of a table format. We had some metadata on top of the data files. So you still have the data files at the bottom. And on top of that, we add manifest file, which is basically adding metadata for different data files. On top of that, we have a manifest list, which is a group of multiple manifest files. And all this stuff all together is exposed in a big JSON file in Iceberg, which is the metadata.json. Thanks to that, we have the ability to group the data files as a kind of tables or views. So the fact that you can create your Iceberg tables using an engine is related to all this metadata. To get this metadata, in the first days of Iceberg, you accessed directly the metadata through a file location. This time is over because now we have a catalog on top of it. So the first purpose of a catalog is, I have this table, give the metadata for this table. So basically, give me the list of all data files for this table and all the metadata. So that's the purpose of a catalog. Keep this in mind because we're going to discuss about that during the Polaris part. So adding metadata on top of the data files bring a lot of new features and bring a lot of values. The first thing is, when you have a catalog in the middle, you can have different engines that use exactly the same metadata. So without the catalog, it means that each engine should have an access to each data file. So now with a catalog, we can say, OK, give me the table A, or table B, or table C. And you can see that for table A, we have a location on an S3 bucket. Okay? The engine is going to use this directly. So that's one of the purposes of the catalog. Another thing that you can see, thanks to the metadata, is all the schema evolution. So you have one table with 3 columns. You want to have a new column. You can go into the metadata and add this. The big advantage is you can go back to previous version of the schema because it all is in the metadata. Another good thing about metadata is about performances. When you have to query a lot of data, what costs a lot is basically scanning and reading all data files. But maybe a bunch of these data files are irrelevant for your query. Like you're gonna on this data file, but nothing is related to the query you want to query. So thanks to the metadata, you can say, okay, I would like to query this, but to query this, I have to go only to this data file, this data file, and this data file. Is basically in the query engines what we name planning. When we do a planning, is we want to anticipate the best reading we want to do for this data. So you can see that thanks to the metadata, I'm going to query only these data files, not the whole data file set. Another thing that you can do is partition evolution. So for performances, we said that we cannot have to query all data files. So it means that in the metadata, you can say, okay, I want to partition this table or view in different group of data files. So instead of having, I would say, like a big bucket where you query everything, you can say, okay, I would like to query per day or per month or per column, for instance. So it's what we name partitioning. And the partition is stored also in the metadata. So if you go in the metadata.json, you're going to see that all the partitioning information. And you can change this partition over time. So you can see that I would like to optimize my query per day, but also per month, depending on the use cases. So as everything is in the metadata, you can say, okay, I would like to change, for this query, the partitioning schema. Is what we name evolution of a schema. Another good feature about partitioning is hidden partitioning. So you don't have to specify the way you want to use the partitions. Depending on the queries, you can automatically get the partitioning. So in the past, in Hive, in Apache Hive, we use something like that, timestamp between this and month, greater than 1 and lower than 4, stuff like that. Now with Iceberg, it's not required anymore. You have only the timestamp, and as you partition by month, you automatically get the optimized query and planning. So that's what we name hidden partition. So I would like to give you a quick highlights about the new features that are coming in Apache Iceberg. So things you have to keep in mind is Iceberg is a table format, is not a query engine, and first is a specification. So in the specification, we describe what is the metadata, how you, what kind of types you can store in a column, stuff like that. Today, so the last version of Iceberg is 1.6.1. That has been released a couple of weeks ago, as far as I remember. The specification supported is V2. So right now, the version is V2. We are working on 1.7 and 1.8. That's going to upgrade to spec V3. And the spec V3 includes new things. So there are some highlights, but I think it's pretty interesting. You may have different view about that. But for me, the first thing is JSON support. So now in Iceberg, in V3, you will be able to store directly a JSON content in a column. So you're going to have some table that will contain JSON raw data, which is super interesting depending on what you store. Position delayed improvement. So I said that we have data files where the data are located. But these data files contain a lot of data. Some data you don't want to read because you consider that it has been deleted. If we delete on storage, the row that we are talking about is not super performant because we will have to rewrite all the data file and so on. So in Iceberg, what we use is delete files. So the delete files is another JSON file that describes, okay, this row in this data file should not be read because it's considered as deleted. We have two kinds of delete files. We have equity delete and position delete. So position delete is pretty simple, is row number X in this data file. It has been deleted. Equity is this line contains this hash map is considered as deleted. So equity delete allows you to bypass all rows looking like this instead of position delete, which is one specific row. And in position delete, we are using it at Dremio in our query engine. And we are working within the community to improve these position delete files, just to optimize the performances and so on. So that's a good thing that it's coming on. Variant data type support, we are discussing, I think it's going to be removed from the V3 in Iceberg and move into Apache Parquet, because we consider that's more a Parquet feature than an Iceberg feature. So I mentioned there because it's going to be included, it's actually already included, I think, in Parquet 1.4.2 release. But yeah, just to let you know, it's starting from Iceberg, but it ends into Parquet. Geospatial support. So we are working with different contributors about geospatial. Location ownership, multi-column transform. So multi-column transform is, I think I showed you before. Maybe I can. So this one, this is a transform. I take a timestamp and I use my month transform function to consider this timestamp is a month. Right now, this transform takes only one argument, which is the timestamp in my case. Now in V3, we're gonna have multiple column transforms. So you will be able to create a month based on the timestamp and maybe another column if you want. Type promotion, we're gonna have also transform to convert from integer and long to string. So that's additional transforms we're adding. And timestamp in nanosecond that has been added is already done. The purpose is, especially for financial data, it's pretty important to have nanosecond support. That's for the spec. Another thing that I wanted to mention is the REST specification. So I'm gonna go back on the REST specification just after. So we have new things like server-side scan planning. So as I said, the engine are using the catalog to do the planification, do the query plan. So now we're gonna have a server-side scan planning, meaning that the catalog can already provide some hints for the engines to optimize the planning for them. So that's a new feature in the REST spec support. Removing partition stats has been added, endpoint discovery, so it means that each catalog can add new endpoints, and these endpoints are automatically returned to the engines, and the engine can react, okay, I have this endpoint for this catalog, so I'm gonna use it or not, and I'm gonna use another path. So that's something that we added recently. Authentication improvement, we want to extend with OIDC, for instance, and stuff like that. So there are new authentication improvements. Why I'm talking about the REST spec is because of the catalog. So the catalog in Iceberg is the first role, as I said, is you give an ID, which is a table ID or view ID, whatever, and the catalog returns to you basically the metadata.json. So that's the first role. So it's a pure meta store. But it's not the only role. We can see new roles like lineage, data governance, lazy snapshot loading, all this stuff. So this is not covered by the Iceberg REST specification, but that's the classic features that the catalogs are adding. So if we took a look on the Iceberg catalog, I would say last year, we had a kind of status quo. So meaning that we have a bunch of different catalogs, the JDBC catalogs, the Glue catalog, the what else? Hive catalog, Hadoop catalog, stuff like that. The problem with all these catalogs, first, they are not all equivalent in terms of features. So for instance, I added the view support in the JDBC catalog, but if you used the Hive catalog, you didn't have view support a year ago. So it means that depending on your use cases, you have to choose the right catalog. That's the first, I would say, drawbacks. Second thing is, not all catalogs are working with all kind of query engines and language. If you use JDBC catalog, you're going to mostly use Java. If you use Python or Rust, then it's going to be pretty hard to use this catalog. So it means that we have different clients depending on the languages you are using. And more than that is, a large organization wants to use the same engine or multiple engines, but with the same data sets. So you can see there, I have my storage with Parquet and Iceberg, and on top of that, I have engines like Snowflake, Spark, BigQuery, Python, Dremio, whatever, Databricks, whatever. Problem with that is, in the past, you had to use one catalog depending on the engine. So you have a different data set, different metadata, and you have a catalog for Snowflake, for Tabular, for Unity, for Dremio, etc. So it means that you have a kind of coupling between the engines and the catalog you were using. And most of the time, when you are using a catalog, you're also coupling with the data sets, so with the storage. So in Iceberg, what happened is we wanted to have something more generic, and it's where we added the REST catalog. So the REST catalog is, in Iceberg, you're going to find the spec and the client. And the client is generic enough to work with Python, with Java, with Rust, with whatever. So you have different clients, but the same spec, basically. But something that you don't have in Iceberg is the REST implementation, the server-side implementation, because it's not the purpose of Iceberg. So you have different catalogs. One at Apache, Gravitino. Apache Gravitino is a catalog. But there are different purposes, and there are some kind of, even at Dremio, we had a catalog. The name is Nessie. Maybe some of you know Nessie. And we have a Dremio catalog based on Nessie. But we have some slightly difference between Nessie or Gravitino and the REST spec from Iceberg. So what we wanted is to have a catalog which is pretty close to the REST spec, but providing an implementation. That's Apache Polaris. So Apache Polaris is a catalog with very focus on the REST implementation and with engine interoperability in mind, meaning that any engine should be able to use the Polaris catalog, and you can switch from one engine to another without changing your data set or without changing the catalog, which is a huge improvement for the ecosystem. So the first thing that in Polaris, you're going to have all what we name data governance, so role-based access control. You define this user or this engine can have an access to this table or this view. I'm going to talk about some ideas for the future of Polaris, but for now, it's the case. So this role-based access control is working with any engine. So you can define something specific for one engine, like Flink is able to access to this table, but Spark is not able, for instance. Or you can also define by users on the engine to the data. So the same user on Flink or Spark may have or may not have access to this table of views. So that's something you can define in Polaris. Another thing that you can say is everything is based on the REST API. So what we agreed inside Polaris is we don't want to fork the Iceberg REST API. That's not the purpose. We prefer to work directly with the Iceberg community and with Iceberg committers and PMC to improve the REST API depending on what we see in Polaris. For instance, some PMC members of Iceberg are also part of the Polaris project, which is a good way to collaborate between communities. Another thing which is important for Polaris is we don't want to force any kind of deployment model. So if you want to run using, I don't know, a tarball deploy on your single machine, and you want to test the catalog there, that's okay. We also provide Docker images. We also provide Helm charts. So depending on the way you want to deploy, then you can support it. So today it's deployed on different Kubernetes environments, so EKS, AKS, GKE, stuff like that. So this is an example of query execution using Spark, Polaris, and accessing the data. So you can see that Spark is configured to use credential from a user, which is Alice. So it's on number 1 there. And Spark runs a query on this table, table 1. And so what Polaris is going to do is first, using the metadata, you're going to check if Alice is able to access to this table, yes or no. And if yes, then it goes to the S3 credentials. So we can have credential vending also between Polaris and AWS. And so we read the table directly from Spark, and you return the content of the table. So that's the kind of use cases you can implement using Polaris. Another thing that I wanted to mention in Polaris is the notion of entities. So as we wanted to have an extendable catalog, table and view is just entities from Polaris standpoint. So it means that if later we want to use UDF, user-defined function, in Iceberg, it can appear like an entity for Polaris. So we don't have to change the whole model in Polaris, adding new things in Iceberg. So namespaces, catalogs, and tables and views are basically entities in Polaris. Something which is a little bit special for Polaris is the fact that you don't have a single catalog in Polaris instance. So you can start one Polaris instance, and this Polaris instance support multiple catalogs. So you can imagine to have one catalog for analytics, another catalog for ML, for machine learning, for instance, stuff like that, but managed by a single instance. About the permission model, I'm going to be pretty fast on that, but basically on the top you have a principal. On principal you have principal roles, and this is global to the catalogs. So all catalogs will support principals and principal roles. And then you're going to have catalog roles specifically to a catalog. So depending on the granularity of authentication and permission you want, you can define at catalog level, which is global to only one catalog, or Polaris level, which is global to all catalogs inside the Polaris instance, which is very convenient depending on the use case and security patterns you want to implement. This is an example. So I'm JB, I'm member of engineer and data team. This is global to Polaris, not for a single catalog. And then engineer has a mapping to catalog admin role in the clickstream catalog. So this is the kind of configuration you can do. You can do some kind of mapping between the top level principal roles and the catalog roles. And you define the different thing you want to do. Some idea about the roadmap and ideas, I would say, for Polaris. The first thing is, today you have two kinds of catalogs in Polaris. The internal catalogs, the one that you create internally to Polaris, and the external catalogs. So for instance, you can have here a plug to Nessie, Gravitino, whatever. Today, these external catalogs are read-only. So you cannot add new metadata to the external catalogs from Polaris. What we want to do is to have a federated catalogs, meaning that all catalogs will look like a single one from Polaris. And so you can add new metadata and create metadata on all the catalogs seamlessly without having to bother about the way it's created and where the catalog is actually located. So that's what we name the federated catalog. That's one feature we are discussing. We have some ideas how to implement that, but it's not yet done. So I'm just sharing ideas. If you have other ideas, please let me know. We are pretty open to your ideas and proposals. Another thing that this is my personal view, okay? It's not yet discussed with the Polaris community. I think that it would be great to have column-based and row-based access control support. So today we have table and views, but why not saying, okay, this user can have access to all rows that contain this column with this value. In terms of data governance, it's pretty interesting. Some features we have in native that we want to contribute to Polaris is, for instance, catalog level versioning. So catalog level versioning means that you can have a tag or a commit for different tables, and you can have some kind of Git semantic in a catalog. Like you can create a branch, you can create a tag, and this tag contains this table, this table, this table at this snapshot or commits, if you know Iceberg. So that's the idea. Another one is multi-table transaction. So as you probably know, when you commit, so you create a snapshot in Iceberg, it's specific for one table only. So with multi-table transaction, we can achieve to have, so today we can work on with namespaces, stuff like that. But what we want is to simplify the life of the users. Like you do a commit on multi-tables, and it's mapping all the commits on each single table in a big one. So that's the kind of ideas we have. That's it. Quick highlight about Iceberg and Polaris. Any question or comment? It's pretty early in the morning. Yeah. Hold on, there's a mic coming. Thanks, Melissa.
It's a fairly simple question. What's the best kind of resource to get up to speed on Iceberg and Polaris? Where's the best place to go?
So the question is, which resources are located in Polaris versus Iceberg?
No, it's much more rudimentary. It's if you were starting out and you wanted to adopt these technologies, where's the best place to go? Clearly.
Training.
Training, right.
At 1 o'clock.
I will be there. Great.
Now, that's a fair question. I mean, how we can start on Polaris, Iceberg, and all this stuff. I think for Iceberg, there are good resources and material you can find. It's not super complicated. I mean, as a user, it's more complicated as a contributor because there are some parts on Iceberg that are pretty difficult to understand. For Polaris today, we are working on documentation. It's a pretty new project, so we need some time to ramp up with a website, documentation, and all this stuff. But again, as a user perspective, I think that it's pretty easy to get onboarded. Contribution, I would say that Polaris is probably easier right now compared to Iceberg. But yeah, I think documentation is the first, and all other materials that you can find, like training, extra, that's pretty helpful.
We try our best with Chill Data Summit. You can always go to the apachefoundation.org and learn about Apache projects, documentation for projects. And then a special shout out to Dremio has a developer advocate, Alex Merced. His content is fire. He's very good at teaching Apache Iceberg and the concepts.
Thanks. Another question?
Hi, Antonello from Wise, just down the road. Thanks for your talk. I wanted to ask, like you were describing Polaris as a federated catalog. So let's say that a company started already working with a glue catalog or another catalog. What will be the role of Polaris there? Because you had a slide, but it's not really clear to me how to integrate, an existing catalog with Polaris. So that will be, interesting for us, for example, because we are already working with glue. Thank you very much.
Yeah, that's a very good question. Is we have an existing catalog. How can I add Polaris on top of my existing catalog or move from an existing catalog to another one? That's where I think that having federated catalog is super interesting. because it means that we will be able to add Polaris features on top of your existing catalog. So if you are using Glue catalog, for instance, just keep it. But we add Polaris on top of that. Welcome. Other question?
JB, thank you so much for everything. Question about transactions. Can you talk a little bit about what role does the catalog play today in transactions, and where do you see the catalog's future is with regard to transactions, multi-table transactions, multi-engine transactions? If you have some opinions on that.
So yeah, thanks. Transaction is, I think that more and more we want to add, historically, Iceberg is an all-app kind of, not all-app kind of project. But more and more we want to have transaction on Iceberg. Like semantically the same as an RDBMS or stuff like that. We can already do that in Iceberg. For a single table, we have ACID transaction support, which work fine. But I think that the objective now is more, as Iceberg is a very popular and large project in a lot of different ecosystems, I think having multi-table transaction is something that we will need, because especially when we're injecting data from different kind of backend, that's very important. Let me take an example. In Apache Camel, I created a new component for Iceberg. So it means that you can consume data from, so today in Iceberg, we have a Kafka Connect component. Camel is more generic, that you can have a REST endpoint putting data, you can have JMS like ActiveMQ, blah, blah. Today, what I did is I take this data, I insert into a single table, and I do a snapshot. I commit my insert. Problem is, it's a single table. So we want maybe to orchestrate the data, distribute on different tables or views, and then we want to commit all as a unique transaction. That's especially true for CDC. When you do change data capture, you want to distribute the data on different tables and commit. So I think today is where the catalog can play a role, because the catalog knows all the tables and views and can orchestrate and map the atomic transaction in a single table, but globally to a more kind of commit statement that is managed by the catalog. So I think that the catalog plays a role there. Maybe last question, because I guess we are running out of time. Yeah, go ahead.
I'm curious to hear your thoughts about the acquisition of Databricks of Tabular, and how does that impact Iceberg, the roadmap, Delta? What are your thoughts?
So I'm going to answer using my Apache hat. I don't have any comment about acquisition, whatever. What I see is, currently in the Iceberg community, is working perfectly fine. So any committer, any PMC member play their role. There are no major question. And to be completely honest with you, we discussed about that at the board level, because it was a question, a fair question. But today in Iceberg, everything is okay. So from an Apache standpoint, I don't have any concern. And actually in Polaris, we have people from Databricks working on Polaris, which is great. So honestly, from my standpoint, I'm pretty fan of collaborative and community-driven, and today everything is okay. So for me, I see that mostly as positive. So yeah, no major comments or concern about that.